Hey, and welcome to another video, Chem with Com. And yeah, let's get started. This is going to be continuation of the last topic, but molecular structure and polarity. We're going to split this up into three different sections. The first section is going to be straight up molecular structure. All right, let's get rolling. Last time we learned about how how atoms start coming together and bonding to form different molecules and compounds. As you can see, they kind of take up different shapes, right? These are different shaped molecules. And so we're going to learn about the different shapes and electron geometries of molecules and how they eventually impact something like called polarity. And eventually we'll learn about something called intermolecular forces, but that's kind of way down the line. All right, well, let's get rolling. Let's continue here. So this is a very sciencey version of the explanation of this. I'll get to my explanation in a second, but we're going to start out with something called Vesper theory, and it stands for valence shell electron pair repulsion theory. Let's break that down. Valence shell, something like carbon, six electrons, six protons. That means we have six electrons. Carbon's on the second row of the periodic table, so it has two energy levels. So it has two core electrons and it has four valence electrons. So this is the valence shell. Electron pair, right? Just pairs of electrons. But you could see, or the last word is repulsion. Well, electrons have negative charges. So what happens is electrons kind of push each other away. And that's, sorry, let's call them sets of electrons. Because of electron pair, right? They're going to push each other away because of the negative charges, right? So all this is saying is that atoms like to stay kind of far apart because they have electrons on the outside and they repel each other. So they want to kind of stay kind of far away. All right. This is my version here. So I'll let you read this one. You could pause it or go through the book, right, and read it. But when atoms start covalently bonding, remember sharing of valence electrons to form molecules, the atoms that are bonding to the central atom stay as far apart as possible. And I'll do a little show for that, but typically what it's going to look like is, let's say we have atom A. This is our center atom. Let's say we have atom B bonding to A. Well, if atom C was coming in from somewhere, right? It's going to bond as far apart from B as possible because that's the furthest place they could be from each other while still bonding to that center atom. It's because of those electron pairs, they're getting pushed away. So imagine getting on a bus and there's one stranger sitting down somewhere, right? Would you sit next to that stranger or would you give them space, right? So that's what atoms like to do. They give each other space. This is because the outside of atoms have exterior on the outside, unbonded electrons, and they are negatively charged. And the same charges repel each other just like magnets from the same magnetic poles. Like if you take a magnet, the north-north side, you try to smush them together, right? You feel the force pushing them apart. Or a north-north, south-south, same thing, right? They're going to repel each other because of those same charges, just like electrons. When molecules start forming, they can take on two and three-dimensional shapes around the central atom, and this is called the electron geometry. And that's what we're going to explore. We're going to do electron geometry, some other stuff, but I'll get into that. So on this next slide, there's a link for this 3D simulation. One way you can do is just write down the link and copy it into your browser. Oops, let's see here if I can do this properly. There you go. Copy. Open up your browser. You can plug that in, right? Or you can just go to Google and type in 3D, oh, sorry, PHET 3D molecules, and it'll pop up here. First link always, or most of the time. Hit the play button and want to do the model, right? So let's take away all the atoms. Let's click on the electron geometry just so we can see what it is. All right, so let's say we have our center atom and we put something in there, right? It's just a straight line. If you'll see on the bottom left of the screen, it says it's linear. We'll go through the shapes in the next slide, but I want to show you this first. And then let's say another atom comes along and tries to bond to that purple atom. What's going to be as far away as possible because those electron and negative charges want to kind of stay far from each other. All right, so the next one is if you have a third, it's still linear, right? If you have a third atom connecting to the center atom, look what it does to those other two. It pushes them down, right? Let's do that again. It pushes them away because, again, they want to be as far apart of each other as possible. And this is called trigonal planar because, look, it's just on a flat plane, right, if you move it around. All right, so now let's put our fourth one. Boom. All right, so you see how it pushed those other ones down? It started out flat, trigonal planar, but now we put the fourth one in, and it's now a tetrahedral. It's a shape is a tetrahedron. I didn't, know of that till I started taking chemistry either. But it looks like a three-sided pyramid, basically, right? And there's going to be more shapes, but we're not going to go into all those. We're just going to stop at tetrahedral. All right, so if you want to take a look at that, please do. It always helps looking at these different atoms, the 3D shapes, using them yourself. All right, so let's get back to the video or the lecture. All right, so again, we're going to do the electron geometry. The book calls it formally electron-pair geometry, but it comes in many flavors, right? The vocabulary. All right, so let's talk about this. We're going to look at the center atom. Center atom, these are the center atoms. These are the connections to the center atom. 1 or 2, 3, and 4. Here it tells us the shape, linear, trigonal planar, and tetrahedral. So what we're going to do is we're going to count regions of high electron density. And those are, I'm going to call those connections, right? Try to keep the vocabulary light, but those are going to be atoms and lone pairs of electrons. We're going to count those, total them up, however many totals we come up with, that's going to dictate our shape. All right, so let's take a look here. Let's say we have two regions of high electron density, 1 or 2, right? If this was 1, and this is the second one, right, we're going to have a linear electron geometry. If we have 3 regions or 3 connections, right, it's going to be 3. Another word for 3 is tri, so trigonal planar. That's a good way to remember that, right? If we have 3 connections, trigonal planar. If we have 4 regions, that's going to be 1, 2, 3, 4. That's going to be tetrahedral. Right, and this is going to be, we'll just do a little column here. Dimensions, right? We have a one-dimensional object here because it's just a straight line. Here we have a two-dimensional object, which is kind of on a flat plane. This is where it gets a little tricky, is the three-dimensional objects, and we'll learn how to draw this in chemistry, right? But we're going to count, and this is going to be around the center atom. All right, we're going to look at the center atom. We're going to count the number of atoms it's connected to, and we're going to count the number of lone pairs it's connected to. And then the total connections will give us the electron geometry. All right, so let's do this. But for this, we're going to have to know how to do Lewis structures. And we're not going to cover that in this lecture, right? That we can go back and look at topic 3, the Lewis structure, bonding, and molecules. You want to look at subtopic 2, Lewis structures and covalent bonds. And that will allow you to do these Lewis structures pretty quickly, right? So go ahead and practice that if you need, and then come back to here. All right. So let's start here. Again, I'm going to do the Lewis structures pretty quick. So carbon, we have 4 valence electrons. Oxygen, we have 6 for a total of 10 valence electrons. We draw carbon and oxygen symmetrically. That's the only way I know of. Then you put your bonding electrons in. So we used up 2 electrons. That means we have 8 left. And we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so you can do either one. It's gonna be the same shape, but you can use carbon as your center atom, or you can use oxygen as your center atom. Let's just use this as our center atom. All right, even though there's 2, we can pick either one because it's gonna be the same shape. Um, so we'll say connected to one atom, right? Carbon, again, we're looking at carbon, what it's connected to. It's connected to one atom. All right. Then let's look at the lone pairs, right? Boom. Carbon is connected to one set of lone pairs, right? These are bonding pairs. They do not count. Bonding pairs. They do not count. All right. So we add those up. We have 2 connections. All right. So if we look here, we have 2 connections, and that's going to be linear, right? Electron geometry is linear. So we'll say electron geo is linear. All right, let's do CO2. So carbon, oxygen, oxygen. We have, what is this, 4, 6, and 6. So we have 12 plus 4, 16 electrons total. So only way to draw this symmetrically, right? It's going to look like this. And let's finish it up. It'll look like this. So now we know exactly what the center atom is. Center atom. All right. So how many atoms is carbon connected to? Well, 1 and 2. Carbon itself has no lone pairs. So the total connections is going to be 2. Since it's 1 or 2 connections, it's going to be linear. Electron geometry is linear. Again, a lot of this is Lewis structures. The only new part here, just counting what's around the center atom, right? So go back and review Lewis structures if you need. All right, let's move on. Let's do something a little different here. CH2O. I'm going to count the valence electrons. 1, 1, and 6. So it's 12 electrons total. The only way I know how to draw this symmetrically, actually, there's a couple different ways, but the one that works is going to be like this. It's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's count the atoms connected. Well, we have hydrogen, hydrogen, and oxygen. So we have 3 atoms. We have 0 lone pairs. So we have 3 total connections. So if we have 3 connections, 3 right? Trigonal planar. And if you're looking at bond angles, I don't think we address bond angles in this class. I don't think we need to. But you can see they're as far apart as possible in 120 degrees. All right, so the electron geometry is trigonal planar. And this is a 2-dimensional object, right? Because it goes this way and it goes this way, right? So there's only two dimensions, so it's a two-dimensional object, trigonal planar because attached to three connections, right? It has three connections. All right, let's do this one, CCl4. All right, so carbon, and we have a bunch of chlorines here. So each carbon has 4 valence electrons. All these chlorines have 7. So we have 32 electrons total. The only way I know how to draw this symmetrically is like this. It ends up being 8 electrons, all right, 1, 2, sorry, 32 total, but 8 electrons to connect them. And then we have 18 more. Let's see, 6 times, sorry, 24 more. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 24, total of 32 electrons. Again, carbon is the center atom. So let's see what's connected to. It's 1, 2, 3, and 4. 4 atoms. These are bonding pairs, remember? Bonding, so they do not count. Do not count. So we have 0 lone pairs. We have 4 total connections. Remember, 4 equals tetra. So 4 connections, tetrahedral. And again, these atoms get pushed as far away as possible. So now this is our first 3D shape, three-dimensional shape. So we're going to have to learn how to draw that. All right, so let's move on. So when we're drawing 3D molecules, right, I'll draw the Lewis structure just so we can remember what it looks like from the last slide. So we had chlorine here. All right, so then we could, yeah, our four connections, we have to draw this in a 3D shape. All right, let's take a look here. So these are the kind of the easy ones. These chlorines, I'll call them chlorine 1 and chlorine 2. And this is chlorine 2, right? Those are straight lines. Those are going to be what kind of considered they're laying on the page itself. This chlorine, we'll call this chlorine 3. This one's kind of coming out at you or away from the screen. Or so it's coming, sorry, it's coming towards you, like from the screen toward you, the viewer. And see how that line is kind of projected towards you? Well, that line is going to be this wedge. It's kind of called a solid wedge, right? And then we have this last chlorine here. This is the hardest one to draw. And we'll call that chlorine 4, and it's going away from you, like kind of away into the screen. So that's what's called a dashed wedge. This is a standard nomenclature, or sorry, standard drawing techniques to show what's on the page, what's coming out at you, and what's going away from you. And you're going to use this kind of over and over again throughout chemistry, right? So again, these lines, the solid lines, are on the screen itself. This wedge, solid wedge, means it's coming out at you. And then the dashes means it's going away from you, right? And again, you need to know how to draw this and practice this. So please practice. Again, I'll draw this here just so you can see me draw it. Chlorine. I always draw it like this. You can draw it many different ways, right? Just like you can rotate a 3D object, you could draw it many ways, but this to me is the easiest. So just practice this. You have the wedge, the solid wedge coming out at you. That's another one. And then you have the kind of dashed wedge. That means it's going away from you. All right. All right, so let's take a look here. Um, let's do water now. Water, H. We have two H's. Each of those has one valence electron. Oxygen has six valence electrons. We have eight electrons total. The only way to draw water symmetrically I know is like this. And we finish this up by putting the electrons on. And so let's take a look now. All right, atoms, we have four, oh, sorry, two atoms connected. Two hydrogens, right? One, two. Here now we also have two lone pairs. For our first time, I think we have lone pairs on this one. Oh, no, no, sorry, we had another one. Carbon monoxide we had. But let's tally this up, and we have four total connections. So the electron geometry is tetrahedral. Now we're also going to look at what's something called molecular structure. I'm going to draw now water as a 3D molecule, right? So it's going to look like this. Oxygen. I'm going to put the lone pairs here just so we can see it. I'm going to put a hydrogen here, and I'm going to put another hydrogen coming out front just because I really want you to see the shape that it ends up being. And then here we have the dashed wedge. Oops, sorry. No more hydrogens. We're not drawing hydronium here. I'll do this in circles just so we can kind of see that they're dots, right? Okay, so now what you're going to do is we're going to find the molecular structure. And this is basically no lone pairs. It's just atoms only, right? The trick you're going to do with this is just cover up those lone pairs with your thumb, and you're going to look at the shape. What does that look like? Well, chemists are not that fancy and not that creative, I guess, especially a couple hundred years ago. They're just going to call it bent, like a bent line, right? So the electron geometry we know because it has four connections is tetrahedral. The molecular structure, again, we're just looking at atoms now, which are the hydrogen and the other hydrogen connected to that center atom. We're going to look at the new shape or the new structure, and that's going to be called bent. All right. So now let's look at that. Electron geometry versus molecular structure, right? Molecular structure is the new one. Um, so here's how I do it. You're going to do your electron geometry, 3D molecule with all the atoms, lone pairs, and that's the electron geometry, right? Molecular structure, you're going to put your thumb out like you're giving me a thumbs up. Close one eye. Where's the camera at? Close one eye and cover up the lone pairs with your thumb, and that's going to be the molecular shape. All right, and so if we go down this way, this just tells us our electron geometry. Right? If we have two connections, we know it's linear. If we have three connections, we know it's trigonoplanar. If we have four connections, we know it's tetrahedral. And then if we go this way, this will tell us our molecular structure. Right? And if there's no lone pairs, it's the linear, let's see. If there are lone pairs, the molecular structure is different than the electron geometry, right? If the there are zero lone pairs, the electron geometry and molecular structure are the same, right? But when you start putting lone pairs in, right? Trigonoplanar with a lone pair turns into a molecular structure of bent. And then sometimes they call it angular, but we almost never say that. Um, if we have a tetrahedral, but one of the connections is a lone pair. It's a trigonal pyramid. If we have a tetrahedral electron geometry and we have two lone pairs, just like water, right? It's going to be bent, right? Because you're going to cover up those lone pairs with your thumb and whatever structure left over, that's going to be your molecular structure. All right, so let's try another one. NH3. All right, valence electrons in N is 5. Hydrogens, we have 1 each. We have 8 electrons total. So we have nitrogen in the center. The only way I know how to draw this symmetrically is with hydrogens on all sides of that, the 3 hydrogens on all sides of the nitrogen. So it looks like this now. All right, let's count atoms. We have 1, 2, 3. 3 atoms. For lone pairs, we have 1. So that means we have 4 connections, 4 total. If we have 4, that means tetra. So the electron geometry is tetrahedral. Let's figure out our molecular structure. Molecular structure. Again, that's atoms only. So we're going to have to draw the 3D shape. So let's do this here. Again, we're going to draw a line and put our electrons in, a lone pair. Another line with the hydrogen. A wedge, that means it's coming out at us or coming out of the screen. And then the hydrogen kind of going away from us or into the screen, right? So yeah, 4 connections. Electron geometry is tetrahedral. You're going to take your thumb, cover up those electrons and see what the shape is. Well, if you look at it, it is a trigonal pyramid. So it's trigonal pyramid. That's going to be our molecular structure. Trigonal pyramid. All right. So let's take a look at this. Let's actually do a quick, just to emphasize our shapes here, to relearn our shapes. This 3D, oops, let's see, it's called PHET 3D molecules. We're going to click on this again. Go here, click on here. All right, so let's take a look here. We're going to be, we'll start out with a tetrahedral, right? If we have a tetrahedral electron geometry and we have no lone pairs, it's going to be a tetrahedral molecular geometry or molecular structure. All right, so then let's take one of these away and put a lone pair instead, right? Well, with one lone pair, the molecular geometry or the molecular structure is going to be trigonal pyramidal, just like the NH3. And let's do one for water where we had 2 sets of lone pairs and 2 atoms, tetrahedral electron geometry. And when you look at the molecular structure, it's going to be bent. All right, so let's try some practice problems now. Let's go back here. All right. Carbonate, a common polyatomic ion. What's the electron pair geometry and molecular structure? Let's do it. CO3, 2 minus, right? Carbon, we have 4 valence electrons. We have 3 oxygens. Each of those has 6 electrons each. Means we have 2 extra electrons. That makes 24 electrons total. We have to draw the 3D structure. Let's do the Lewis structure, sorry. COOO. And we have to put our 24 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, that's it. All right. So this oxygen's happy. This oxygen's happy. This oxygen is not happy because it wants 8 electrons because of the um, octet rule, right? So if it's not happy, it's going to share with its neighbor. So it's going to look like this. C, O, O, O. But here we're going to have 2 sets of electrons. Here we're going to have 3. The proper way to do it is you box it up, put a 2 minus. Now let's count the lone pairs and the atoms, right? Here we have 1, 2, 3 atoms. For lone pairs, no lone pairs, right? So that's going to be no lone pairs. So the total connections is going to be 3. So if we were going to draw this in a proper way, it's going to look like this. Carbon, it's going to be kind of like a Y, right? Because we have this oxygen up here. We're going to have this is kind of like let's do the 3D structure. It's all going to be on the same plane. So it's going to look like this to the oxygen, this to the other oxygen, and then we're going to have a double bond down here to the other oxygen. Right? So it's going to look like that. And with the 2 minus, and that's going to be electron geometry of trigonal planar. Now, since the CO3 does not have any lone pairs, the molecular structure is going to be the same thing. Trigonal planar. Because there are no lone pairs on the center atom. So it's the same thing. All right, let's continue. Let's do another one. Hydronium ion H3O plus. So we have hydrogen, 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 and an oxygen. 1, 1, 1, and 6. That plus means we subtract 1. So it only is 8 electrons. We're going to draw H3O symmetrically. H, H, H. 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. We're going to count the atoms. And then we're going to count the lone pairs. Well, we have 1 lone pair. Here we have 3 atoms. 1, 2, and 3. We have 4 total connections. So that's going to be an electron geometry of tetrahedral. Now we have to draw the 3D shape to figure out the molecular structure, or you can use that table. We can go back and check the table out. All right, you're going to take your thumb, cover up the lone pairs. And that's going to be what's called trigonal pyramidal. All right, so again, we have 3 atoms, 1 lone pair. Let's go back here. Right, we have 4 total connections, so it's going to be tetrahedral. Then we want to look over here and figure out, hey, we only had 1 set of lone pairs, so now the molecular structure is going to be trigonal pyramidal or trigonal pyramid. All right, well, that's it. Thank you very much, and I will catch you on the next video. Thank you very much.